Okay, so I figured it'd be good to go through this in a just in general for a big polynomial function, finding all these different parts to it and everything, and making sure it all kind of makes sense to you. So when you do it in Desmos, I will say it is easier. Like you're going to find that you can just click on the points and you can find them, and it's going to snap right to the spots. And if you're doing it at home and you don't have a graphing calculator, that's the way you're going to do it. If you have a graphing calculator, it's definitely worth kind of making sure you understand how to use it. If you have your own, you should, or if you borrow one or whatever, you want to make sure you know how to do the steps. So if I were you, I'd do both if possible. If not, just do the one you have. So let's go ahead. I'm going to do it in the graphing calculator because, like I said, the Desmos is pretty simple. You're just going to click on the spots and it's going to give you the coordinates. So we're going to type this guy in, and we're going to go from there. That's a lot of twos. Okay, 2x squared minus 5. Okay, so negative x to the fifth, 2x to the fourth, 2x to the third, 2x squared minus 5. Perfect. Okay, graph. Okie dokie. So it looks like this graph comes down, goes up, comes back down. I'd like to see this because this is one of the things I'm going to need to find. So I could zoom out, and that's sometimes okay. I'll show you what I mean. So if I zoom out, I press enter and I zoom out, sometimes this kind of scrunches it up and it just doesn't, like, you could work from this, but I don't really like it. So what actually I find a little better, let's go back to the standard window. So zoom 6 here. Is really all I want is to just see a little bit higher. If I could just make this part go a little higher, I'd see what I want. I want to see that peak up there. So I'm going to go to my window, and I'm just going to make my Y max a little bigger. So instead of only going up to 10, let's have it go up to, like, I don't know, 25. Just kind of picking a number, seeing if that will work. So I'm going to make it go higher on the Y axis. And let's see if we can see that peak. All right, perfect. So I just kind of picked a number, maybe try 20, maybe try 30. You sort of play around until you can find it. But now this looks pretty good. Now I can see all the things I want to see because I want to find relative maximums, relative minimum, x-intercepts, which there's several, and y-intercept, which looks like there's just the one. All right, so as we kind of look at this, we do see this graph has 2 turning points. It has a turning point here. It's got a turning point here. And basically we just need to find those values and get everything out of this. So let's start with the relative maximum. So obviously, like, the maximum of this graph is infinity because it goes up there, but they refer to this as a relative maximum because it's like a peak in this area. So either way, to find it on the calculator, you go to your calc menu, and you want to find the maximum because that's what we're looking for here. So this is where it does the left bound and the right bound stuff. So you got your maximums up here. So for left bound, you want to be a couple clicks to the left. You press enter. You go a couple clicks over here to the right. As long as you're past it, you're good. You press enter. And then for guess, you just put it about where it's at and press enter. And then it's going to give you the coordinate. And a lot of times these are going to be pretty messy coordinates. So, I'm going to just round these to like the nearest 10th. So I'm going to say 2.3 and 21.5. Okay, and so this graph just has one relative maximum. And so that's it. I wrote it down. I'm good. Now it's also got this relative minimum over here. So we can move on to the next question. And it's really the same process, just when you go to your second calc menu there, now we're finding a minimum. So we pick this one, we slide on over to here, and we go left bound, right bound, and guess. And so this minimum here happens to be at 0, -5. Cool. Which appears to also, which is just the y-intercept. That's kind of a coincidence on this problem, which is fine. But let's keep on rolling. So now we move to x-intercepts. There are 1, 2, 3 spots where this crosses, so we need all of them. You can go to so just as a shortcut, sometimes, you can go to your table, and you can look if, do any of these inputs give us a 0? And so we see actually that 1 gives us a 0, and that's really the only one. So one of our zeros is 1. This one right here does cross at 1. These two, though, are going to be at decimals. So you can save yourself a little time sometimes if you look at the table, but not always. So anyway, x-intercepts are zeros. So we pick 0, we go over to here, and it's the same left bound, right bound stuff. So we go left, we go to the right of the 0, and then we put it near the 0 and press enter. So that one is at -1.1, approximately. All right. We already said we saw this one was at 1 from the table. Granted, if you didn't go and do that, you can just get it this way too. So you can go left bound, over here, right bound, and then guess, and you'll see it's at 1, like we already knew. And then we repeat it one more time over here for this one that looks like it's at about 3, but probably not exactly at 3. So left bound, right bound, guess, and it's at 2.8, 2.9, about 2.9 if we round it up. Okay, and so those are our 3 x-intercepts from the graph there. All right, y-intercept, we already knew it. Now, you don't even need a calculator to do y-intercept. Remember, this value here, if there's a just constant term being added or subtracted, that's the y-intercept. And if there isn't one, then the y-intercept's at 0. So in this case, our y-intercept is just at -5. And there we go. So the main point of this was calculator. If you're doing it in Desmos, you should be able to just click on any of these and it'll snap right to like the min, the max. It'll snap right onto these. So you can do that too. That's obviously a lot more easy. But I want to make sure that if you have this or you're using this, you understand how it works because, this is what the calculator is, which you can use on like SAT and other stuff like that.